So we're told that we don't want to exceed an angular velocity of 2400 revolutions per minute. So let's go ahead and change that to radians per second to see what we're dealing with. We know there's 2 pi radians for every 1 revolution, and we know that we have 1 minute is 60 seconds. Do this and you get about 251 radians per second. And now if we look at the side view, we notice that the velocity of the plane relative in air is 75 going horizontally. The tangential velocity is pointing downwards, so we can say that the velocity of the tip squared equals velocity of the plane squared plus tangential velocity squared. So this equals v plane squared plus the tangential velocity is r squared omega squared. And if we solve for r squared, we get it's the tip speed squared minus the plane speed squared over omega squared. And this means that r by itself is the square root of that quantity. Tip squared plus minus, sorry about that mistake, minus v plane squared over omega squared. Let's plug in the values. We have a tip velocity of 270 meters per second, quantity squared. Velocity of the plane is 75 meters per second, quantity squared, all over 251 radians, quantity squared, and that gives us about 1.03 meters. And now if we wanted to find the radial acceleration, we can use omega squared r, which is 251 radians per second squared times r, which we just found to be 1.03, and that equals 6.5 times 10 to the 4th meters per second squared. The tangential acceleration, if we know, is going to be 0. Excuse me, because the angular velocity is constant.